So, what is the hypothesis? So, we talk about hypothesis test for a proportion. So, today we want to discuss what is meant by hypothesis test for a proportion. First, to clarify, hypothesis means an educated guess. So, hypothesis is an educated guess. Educated guess about a population proportion of success. Sorry, this should be, just leave it alone. Why do we make an educated guess? Make an educated guess about a population parameter. About a population parameter. Okay, have you ever thought about it? Why? Why do we make an educated guess about a population parameter? And the reason is very simple. Reason is it's very difficult to reach the entire population. So let me give you an example of this. Example. Suppose I want to find out what proportion of students at a college has laptop computers. Cannot reach the entire population at one time. Cannot reach the entire population easily. Therefore, work with a simple random sample. A simple random sample of 50 students. Okay. Suppose out of those 50 students, "35 have laptops." So the sample proportion also given by the symbol P hat of students who have laptops is P hat is 35 students have laptop out of 50 is 0.7. Okay. So suppose, let me change the color of the ink now. Okay. Next, I hypothesize that the population proportion P of students with laptop is 0.68. Notice notice that my sample proportion P hat is greater than the hypothesized value of population proportion P equal to 0.68. So hence we can do a hypothesis test like this. Test where H0 is your null hypothesis. Okay. P is equal to 0.68. Okay. I made a mistake here. Let me correct that. No, I did it correctly. So So my P hat sample proportion came out at 0.7. I made an educated guess or hypothesized that the population proportion of students with laptop is 0.68. And my sample proportion is greater because it's 0.7 is greater than the hypothesized value of 0.68. So my null hypothesis, my educated guess, population proportion is 0.68. And my alternate hypothesis is P greater than 0.68. Okay. So we will calculate a test statistic which is a characteristic of the sample that we have gathered. Okay, so how do you calculate the test statistic? That is my next question. The test statistic is a characteristic of the sample that we have gathered. Basically, we will compare the sample proportion to the hypothesized value of the population proportion. Sample proportion came out as 0.7, population proportion hypothesized is 0.68. So the test statistic, let me change the color of my ink. The test statistic is the z-score of sample proportion, p hat. Remember, z-score is given by x minus mu divided by sigma. It means how many standard deviation the value x in the population, or the value x in the sample actually, is away from the population mean. Same idea is applied here. Okay, so we will compare. So test statistic z will tell us, let me erase that. Test statistic will be z will tell us how many standard deviation is the sample proportion p hat away from the value in the null hypothesis, value p in the null hypothesis. So the z test statistic will be test statistic c will be p hat minus p in the null hypothesis divided by square root of p times 1 minus p over n. So the whole thing is divided by. Now square root of p times 1 minus p over n is the standard deviation of the sampling distribution or probability distribution of p hat, of sample proportion p hat, assuming the value in the null hypothesis is true. Now so this is calculated as square root of, so this standard deviation is given by, or standard error of the sampling distribution is equal to, in this case, is square root of 0.68 times 1 minus 0.68 divided by sample size of 50. Okay, and that works out to 0.066. Okay, hence the test statistic is Z is equal to P hat minus value in the null hypothesis divided by 0.066, which is equal to P hat, remember, is 0.7 minus 0.68 divided by 0.066. So test statistic Z is equal to 0.303. This is the test statistic. Okay. Now remember, this is a right tail test. How do you know that? Just because H0 is P equal to 0.68 null, and the alternate is P greater than 0.68. So the two slanted lines indicating greater than is pointing to the right. So this is a right tail test. That means the rejection of H0 region will fall in the right tail, of the Z curve, of the standard normal curve. What do I mean by that? Let me show it to you by drawing a picture. So this is your standard normal curve or Z curve on the horizontal axis. At the center where the peak is highest is mu equal to 0 and sigma of this curve is equal to 1. This is the standard normal curve, normal probability distribution. Do you get it? What I'm trying to see is where the value, remember the test statistic is 0.303. So at the center I have Z equal to 0 at the center. And my test statistic is 0.3, how much is it? 0.303. So somewhere over here. And I draw a vertical line at 0.303, and if I change the color, this is the area. We want to find out what is the probability of obtaining a test statistic at least as extreme as z equal to 0.303, or in other words, what is the area under the standard normal curve to the right of z equal to 0.303. Okay, to the right. Why to the right? Because it's a right tail test. Okay, so we can use our calculator for that, and if we use our calculator, we can use TI-84 for example. Okay, so using TI-84, press second button, then verse button on the third row of the calculator, and then number 2, which is normal CDF function, normal cumulative distribution function. My lower, although the calculator has a tendency to set the lower at -1 E99, in this case we start our calculation, we are on the right of 0.303, so my lower is 0.303. My upper is a very large number on the right hand side, all the way to the right is 1 E99, that is 1 followed by 99 zeros or infinity, or we write it in the calculator, we type 1, then we press the second button and then the comma button. Where is the comma button? It's on the top of the 7 button, gives me capital E 99. Leave the mu at 0 and sigma at 1. As I mentioned in the past, this is the characteristic. This is mu equal to 0 at the center, and sigma is 1 for the standard normal curve over here, as mentioned over here. Okay, so leave the mean at 0, standard deviation as 1, put your cursor on PEST and hit enter twice. Remember, when you are on PEST, hit enter twice. So the probability of z greater than 0.303 is equal to, by the calculator, 0.381. Now in this particular problem, we were not given a level of significance. When level of significance is not given, assume level of significance is equal to 0.05. What is this level of significance? Level of significance is the maximum probability, of rejecting 80 when it is true. That is, we make a wrong decision. Okay, so before I carry out any further, I'm trying to do a hypothesis test for a population proportion. So I'm going to make an educated guess about the population proportion, because I cannot reach the entire population. Before that, I will collect a simple random sample from the population, maybe a sample size of 50, and 35 out of 50 students have laptops. So my sample proportion of students who have laptops is given by p hat is 0.7. My educated guess about the population proportion is 0.68. Since my sample proportion is greater than the my educated guess of population proportion of 0.68, I will write the null hypothesis. Remember, hypothesis testing always come in pairs. So I'll write the null hypothesis as population proportion equal to 0.68 and the alternate p greater than 0.68. The two slanted lines indicating greater than meet at an edge pointing to the right. Therefore, it's a right tail test. Okay. Before I go any further, please subscribe to my channel by hitting the red subscribe button, and please give me a strong feedback by clicking on thumbs up. It really motivates me. So go ahead and please click on the thumbs up. So now continuing where we left. So we calculated the p-value, the probability of obtaining a test statistic at least as extreme as 0.303, and that came out as 0.381. Now this probability, compare the probability value, sometimes called the p-value, associated with the test statistic with the level of significance, which is the maximum probability of making a wrong decision, sometimes called alpha. This is Greek symbol alpha. We notice in this case P is greater than alpha. In that case, the decision is fail to reject H0. Okay. That means the sample came from a population which most probably has a population proportion value of 0.68. So although the sample proportion was 0.7, it is maybe just due to chance, and the sample quite likely have come from the population with a population proportion of 0.68, although the sample proportion was 0.7. It's so little away from the hypothesized value in the null hypothesis, population proportion 0.68. Hence, we fail to reject H0. And our conclusion is at alpha equal to 0.05, there is not enough evidence to support the alternate hypothesis, which states P is greater than 0.68. So let me highlight my decision is fail to, oops, I don't want that. So I will erase it. And write it again. Fail to reject H0. Reject H0, which states that P equal to 0.68. I wanted to highlight it, and the highlight is done in this way. Fail to reject H0. P is 0.68. And what is my conclusion? At alpha equal to 0.05, there is not enough evidence to support the HA P greater than 0.68. But the crucial is fail to reject H0 because probability of obtaining a test statistic at least as extreme as what we have obtained is greater than the level of significance. Okay, I stop here today. If you like this video, please give me a thumbs up. I'm mentioning again, please give me a thumbs up. This really motivates me. Please take care, and if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I will see you next time, and please do not forget to click on the bell button. That will notify you every time I upload a new video, which I do quite often. So please give me a thumbs up and do not forget to watch me tomorrow when I'll be